Welcome to Career Guidance Max playlist. So in this video we are going to see unit 5 Z transform. In this Z transform you will have lots of formula, lots of sections, but in this I am going to teach only convolution method. Why? Because in this convolution method definitely you will get 8 mark from your university question paper. It's very simple only. So before that we should know the convolution formula, that is Z inverse of f of z into g of z we written is equal to sum of m equal to 0 to n. First function m, second function g of n minus m. That's very important, m and n minus m. So this z inverse of f of z I am going to split z inverse of f of z star. This star is represent convolution operator, and z inverse of g of z is equal to sum of m equal to 0 to n f of m g of n minus m. So this z inverse of f of z we can write f of n. Usually in z transform we are writing z transform of f of n is equal to f of z. Here we are taking inverse z transform. So that z inverse of f of z we can write f of n. So in that model here we can write z inverse of f of z equal to f of n. In similar model z inverse of g of z equal to we can write g of n is equal to sum of m equal to 0 to n f of m g of n minus m. If you want to solve the problem in convolution method, first you should know the formula, the very basic formula z transformation of a power n equal to z divided by z minus a. Based on this formula you will have 5 problems in this convolution method. Very simple one. You should memory this formula z transform of a power n is equal to z divided by z minus a. So after that in this section you will have 3 more formulas. While doing problem we have to apply those formulas. So these are geometric progression. Last one is arithmetic progression formula, nth term. So first two, 1 plus x square up to xn is equal to, we can write the formula 1 minus x power n plus 1 divided by 1 minus x, when x value always less than 1. If it is this x is less than 1, we can apply 1 minus x power n plus 1 divided by 1 minus x formula. Otherwise, suppose x greater than 1, this x is greater than 1, we can apply the formula x power n plus 1 minus 1 divided by x minus 1. Whenever we will get the term up to n, we can apply n into n plus 1 divided by 2, the summation 1 plus 2 plus 3 plus final one up to n is equal to n into n plus 1 divided by 2. So in this section, very simple to understand the problem. You should know only the one formula, and you should know one formula z transformation of a power n equal to z divided by z minus a, and this geometric progression 2 formula. Here you may get confusion. So 1 minus x power n plus 1 divided by 1 minus x, whether it is x greater than 1 formula or x less than 1 formula. So that here you can memory one formula, x less than 1 you can memory 1 minus x power n plus 1 divided by 1 minus x formula is our x less than 1 formula. So opposite is greater than 1 formula. So you can memory like this. So it will be very easy. Now I am going to start problems. The very first problem in this convolution method, find z inverse of z square divided by z minus a into z minus b by convolution method. So here you should understand one concept, what it is, and z inverse of z square divided by z minus a into z minus b. So this z inverse, this convolution method under comes from inverse z transform. In this inverse z transform you will have 3 model. One will be partial fraction method, another one Cauchy residue method, and the final one convolution method. So that I am taking first convolution method. In this convolution method definitely you will get 8 mark from your university question paper. But here you will have one problem. What it is? This z square divided by z minus a into z minus b. You should understand how to split this term z square divided by z minus a into z minus b. According to our formula, z transformation of a power n is equal to z divided by z minus a. According to our formula, we have to split this term. So I am writing z inverse of z square divided by z minus a into z minus b. So you may get confused while splitting the term. So z inverse of I am writing z divided by z minus a. That z square I am splitting as a two term. Z divided by z minus b. Then I am splitting this term z inverse of first one z divided by z minus a, and convolution operator z inverse of z divided by z minus b. Okay. Then already I told here I am going to apply the formula z transformation of a power n is equal to z divided by z minus a. Suppose here z divided by z plus a, now you can take z transformation of minus a power n. You will get simply. So from this I will write a power n is equal to z inverse of z divided by z minus a. Most probably in convolution method we are applying this formula z transformation of a power n. When z shifting to right hand side, you will get the inverse z transformation of z divided by z minus a equal to your answer a power n. So that here I am writing z inverse of z divided by z minus a means I am writing a power n, and the convolution operator star this z inverse of z divided by z minus b na just replace by b, a by b. You will get b power n. Now it is understood it is a form of first function f of n, second function g of n model. So by convolution method, what it is convolution method formula? F of n star g of n is equal to sum of n is equal to 0 to m is equal to 0 to n. First function f of m, second function g of n minus m. So this formula here I am going to substitute. Consider f of n. Consider f of n is a power n and g of n is b power n. In your formula, first function n replaced by m. So that I am writing sum of m equal to 0 to n. In first function n replaced by m, so that a power n I am going to write a power m because n replaced by m. In second function g of n minus m, here your second function b power n. This b power n I am going to write b power n replaced by n minus m. Okay. Now we are going to apply simplification method. That's it. Very simple one. A power m. This b power n minus m I am going to write b power n into b power minus m. Here this b power n is constant. Why it is constant? We have to substitute the values for m. So except m term, remaining all we can take outside of the summation. So I am taking this b power n outside, and the sum of m is equal to 0 to n. I am writing a power m. This b power minus m, how to convert that power minus? Take a reciprocal 1 by b power m. The power will be converted. Now here the both the term power will be same, so that we can able to write b power n sum of m equal to 0 to n. Combine these two, a by b whole power m. Okay. So after that we can able to apply our value m equal to 0 to n number of times. So bn, first one you can substitute m equal to 0. So a by b 0 plus sum is represent plus, and you can substitute 1, a by b whole power 1. Next you can substitute 2, a by b whole power 2. Next you can substitute up to n number of times. Final one, a by b, I am going to substitute m equal to n. Here we may write anything power 0 is 1. So according to that I am writing bn outside. Here a by b, anything power 0 is 1. This is a by b, and a by b whole square plus a by b whole power n. This is our series. So this series you can compare. Already I told the formula 1 plus x square plus x power n is equal to 1 minus x power n plus 1 divided by 1 minus x, or x power n plus 1 minus 1 divided by x minus 1. Here you will have two formula. X less than 1 formula, x greater than 1 another formula. So after this, based on this series, I am writing the formula. So what is the formula? What is the formula we can apply here? The formula is 1 plus x square xn is equal to 1 minus x power n plus 1 divided by 1 minus x. I taken this formula. If x less than 1 means we can use this formula. Why I taken this formula? Because here you can compare both the term. You can compare the terms 1 plus a by b. Here 1 plus x, like that. Here we don't know what is the x value. Here we have generally a by b. We don't know the exact value of a by b. If it is you will have here 2 now, we can compare. X value is less than 1 is not possible. This is x greater than 1 form, because consider this a by b is x. So generally here we can apply any formula, 1 minus x power n plus 1 divided by 1 minus x formula, or you can apply x greater than 1 formula also. So x power n plus 1 minus 1 divided by x minus 1 formula also we can use. Here I am using x less than formula generally. If you want to use x greater than 1 formula, you can use it. So compare these two equation. What is your x value? X equal to here a by b, right? Here x equal to a by b. This a by b I am going to substitute in our general formula, 1 minus x power n plus 1 divided by 1 minus x. So that I am writing here b power n, and this is I am going to write 1 minus x will be a by b whole power n plus 1, okay, and divided by 1 minus a by b. This is our substitution final value. Now I am going to simplify this term. I am writing b power n outside, and here 1 minus a power n plus 1 divided by b power n plus 1, okay, and whole divided by, take a LCM, cross multiply, b minus a divided by b. So I am writing b power n, b minus a divided by b, you can shift to numerator, you will get b divided by b minus a. And here I am taking again cross multiply the term, b power n plus 1 minus a power n plus 1 divided by b power n plus 1, okay. So here b power n and b power 1 both we can multiply, power we can add, b power n plus 1 divided by b minus a. So here b power n plus 1 minus a power n plus 1 divided by b power n plus 1. So now I am going to cancel this b power n plus 1. So I will get the answer b power n plus 1 minus a power n plus 1 divided by b minus a, which is the answer for z inverse of z square divided by z minus a into z minus b, okay, is equal to b power n plus 1 minus a power n plus 1 divided by b minus a. Suppose if I am taking x greater than 1 formula, means you will get the answer a power n plus 1 minus b power n plus 1 divided by a minus b, you will get. Here our problem will be, I taken generally z square divided by z minus a and z minus b. Instead of a, b, I'm going to change 3 and 4, 1 and 2 and 5 and 4, 5 and 6 or anything 7 and 8. Now, according to that, we can able to proceed the problem. The very simple, this method again you have to proceed, or generally you can write ab equal to this and ab equal to this value. So finally you will get the answer like this. So you should remember here, while attending the problem in a convolution method, you should remember always this formula. This 2 is very very important. And then z transformation of a power n equal to z divided by z minus a. Most probably we are applying only this formula in convolution method. Minimum 5 problems are we are doing based on this formula. And f of n star g of n equal to sum of m equal to 0 to n f of m g of n minus m. First function replaced by m, second function replaced by g of n minus m. You should remember that. And one more thing, you should understand how to split this z square divided by z minus a into z minus b. If you know z divided by z minus a into z divided by z minus b, now for our convenience we have to split. So if you able to split this term, this method is very easy. You can apply in inverse z transform, any formula, any problem, you can apply this method. But the only the thing is, you should split the term according to our formula, otherwise it's difficult. But this problem will be very easy. Just we substituted the formula a power n b power n, that's it. Thereafter first function replaced by m, second function replaced by n minus m, and simplification of the terms. Finally we substituted this formula while doing here 1 plus a by b plus a by b whole square equal to, consider 1 plus x square and x power n, general term. You can compare. So when comparing general term, here I taken the formula 1 minus x power n plus 1, 1 minus x, because we don't know the value of a by b. If it is 2, generally we can take x greater than 1 formula. If it is less than 1, we can apply less than formula. It is a by b. So I taken general formula 1 minus x power n plus 1 divided by 1 minus x. So here I substituted and we simplified the term. You will get the final answer b power n plus 1 minus a power n plus 1 divided by b minus a. Okay. Thank you, Pa.